Hello, my name is Saedak Yuri and I am presenting you a method of prosthetic vision developed with my mentor Koldun Victor. Recently, the technological progress caused great influence on people's method of movement. Nowadays, everyone has a wide choice of means of transport, beginning with public transport and ending with monowheels or electric scooters. But unfortunately, this development did not touch people with sight problems. They still need to use a stick or ask for help of a guide. Moreover, this development caused even more problems to them, as nowadays on the streets even more dangers to them. More people use bicycles and more obstacles appears and move faster around them. The logical question is, why is such an important problem still unsolved? The answer lies in the structure of our brain, namely in the high amount of information transmitted from our eyes to our mind. This is why the real prosthetic of eye is impossible. However, to avoid problems and move safely, you don't need to know the color of the table. It is enough just to know, you don't need even to know that it is a table. It is enough just to know the direction and distance to the table to move safely. Knowing this, the amount of information needed to be transmitted to our brain greatly decreases. And with proper form of transmission, our audio channel can cope with this. So, the problem is finding this method. During the experiment I considered two different methods, verbal form and sound of notes. And as it proved to be, verbal form has several significant drawbacks. To better understand them, we need to go into our brain structure. Hundreds of branches with receptors at the ends depart from it. Auditory receptors are mechanical resonators that respond to fluctuations in a specific frequency. Therefore, the sound of one note is transmitted by significantly fewer signals than the sound of word. Also, the use of notes allow you to keep the acoustic channel working. After all, even from the experience of telephone communication, it is known that when cutting several frequencies from the signal, its legibility does not suffer. Another advantage of note is their simplicity. One note consists of one phoneme and directly goes to the decision-making unit, when a word consists of several dozens of phonemes which should be compared with already existing ones and only then may be processed. To test the theory, several prototypes were developed. Here is prototype on the platform of Raspberry Pi. Currently it has 4 ultrasonic sensors. Each sensor has its own zone. Zones are divided into smaller pieces. Each piece is matched by color. Color means the distance to appeared obstacle, and also it shows the volume of appropriate note. When any obstacle appears in front of the sensor, Raspberry plays appropriate note of appropriate volume. To sum up, this prototype proved that it is really possible to create a small autonomous device that will allow sight-impaired people move safely in spaces with moving obstacles.